What is artificial intelligence really? I work in AI, and my friends often ask, Tyler, can computers really be intelligent? And my answer is yes, they can and they are. Intelligence isn't some nebulous moving goalpost of a definition. What they're really asking is, can computers be conscious? That's your nebulous. And the answer is maybe. Intelligence. The ability to acquire and apply knowledge to effectively model the world and achieve goals under uncertain conditions. 3 parts. In the journey of AI, we started with code, computer programs, apps, scripts. These achieve goals, but not in uncertain conditions. No, they're deterministic. Clicking a button likes a video. This concept is called a function, and in later content, that concept will return, because modern neural networks are sometimes called universal function approximators, meaning through one lens, what they're doing is inventing code on the fly. So programs aren't full intelligence. Enter the GOFAI era, good old-fashioned AI, the Dartmouth Summer Research Project of 1956. The phrase was coined, and subdisciplines were introduced: knowledge representation, planning and decision-making, natural language processing, perception, and most importantly, learning. You'll see why later. The essence was to turn deterministic programs non-deterministic. Heuristics, rules of thumb, fuzzy logic. Given a scenario I know roughly something about, can I still achieve the goal? This isn't if-thens. This draws upon fields of statistics, probability, information theory, and calculus. Many of these algorithms are still in use. SLAM in robotics, A-star in pathfinding, and more. One missing piece: acquire and apply knowledge, aka learn and adapt. Enter machine learning, or ML. Now, ML's been around since AI's beginnings, but the real magic started in 2012 with Geoffrey Hinton and team. Long story short, they made machine learning scalably feasible with data and GPUs, after which ML started being applied in all the subdisciplines. Learning to see is more robust than programmed to see with uncertainty, and the rest is history. Artificial intelligence, done deal. But you're thinking, I don't feel like it's AI. Where's my household robot maid therapist who plays tennis and feeds me grapes? That would be AGI, artificial general intelligence. Before I define that, let me define the extreme, ASI, artificial superintelligence. Its definition is anything we can do, it can do better. Sounds like a brand. This is your sci-fi Borg god running the planet powered by a computronium megastructure built around the sun. But ASI is simply defined as it can do anything and everything we can do, but better. So the in-between is AGI, which means AI that can do anything and everything we can do, full stop. Not better, not even necessarily as good as, just that it can do anything we can do. It's general purpose. Hand it a broom, show it how to sweep, and it can learn the ropes. Put that same bot in a car, and it can learn to drive. To get general, we need to package the disciplines together. NLP, perception, planning, knowledge representation, all driven by learning, shoved into a robot body, a walking, talking, seeing, thinking robot that can generally do everything, not necessarily well. We're closer than you think. You're going to start hearing that term a lot in the media, AGI. And when AI can improve itself, the pace towards that goal will accelerate exponentially. They call this the singularity. So intelligence, programs and apps gave us achieve goals. Good old-fashioned AI gave us under uncertain conditions. And machine learning gave us acquire and apply knowledge. And deep learning with neural networks put ML on steroids. We have AI. We're close to AGI. And then someday, ASI? To get the deep dive, listen to my podcast Machine Learning Guide at ocdevel.com/MLG. It's an audio course in podcast form that teaches machine learning. If you're non-technical, you can stop before it gets into the weeds. There's plenty of just for fun episodes.